Security Part 2. In this nugget, we continue our discussion of security, and this is Part 2. We start off with a discussion of software update services, and this is going to be great because it's going to be able to allow you to deploy updates throughout your organization without touching any of the machines if you don't want to. We'll take an overview, a look at how to use SUS, how to install it, as well as how you can configure group policies that allow SUS to work with your clients. And then we'll take a look at some insecure packets across the network. How about if you put a packet sniffer on your network right now and capture some packets, you're going to see some insecurities there. Some of them might be all right, might be public information that's available for anyone within your organization. Some of them might also be passwords, however. So we'll take a look at that kind of thing. Then we'll see how we can protect those sensitive packets using IPsec, and we'll start off with a discussion of what its functionality is, what it's capable of doing, primarily authenticating the sender and receiver of packets, as well as encrypting them. And then we'll take a look at the default policies that are already included with Microsoft Windows products, as well as how to deploy those policies or to create your own. We'll look at how to deploy the policy using a group policy object or using them on a local machine only. Well, now that you've gone ahead and checked out Microsoft's Baseline Security Analyzer, you might have realized that you got a whole bunch of systems on your network that are not secure because they haven't been downloading the latest patches and updates from Microsoft. So what are you going to do? Well, you probably are aware of the fact, even from running Windows XP on your home computers, that you can always go to Start, All Programs, and then go to Windows Update here. And then if you've never configured this before as an administrator, the first time you run it, it'll ask you to go ahead and configure Windows Update. In our case, I've already done that at some point in the past, so we don't really see that here. However, once we get to this and it loads the web page, we can just click Scan for Updates, and it'll tell us if we're missing any critical updates and service packs. Now, that's going to be great. If I see anything in that, I can then click it and then install it. Now, here's the fallback to this. Here's the problem with this. If you're not an administrator, you can't even get this far. It won't even let you scan for updates if you're not an administrator. And this is going to mean that you're going to have a lot of very busy help desk folks or administrators running around to every single desktop and server within your organization. Now, quite frankly, the desktops are probably going to fall through the cracks from time to time. But the servers absolutely have to have the latest updates and service packs, in addition to whatever virus protection software you're using. Now, there are third-party products that can automatically deploy those things. There's also SMS, which you can use to deploy those things. And you can use SMS in conjunction with something called Software Update Services, because there's an add-on that makes the two work together. On the other hand, if you don't have budgeting for SMS or third-party products and you still want an easy and convenient way to automatically deploy updates to your clients and servers, you can use Microsoft's own Software Update Services. And what this does is it kind of takes the place of Microsoft's own Windows Update website, and it kind of places your own Windows Update website within your own corporate firewall. And that way you can have your clients download their updates from your server, and they can also be updates that you've previously tested and approved of. Once you've approved of them, then they can automatically download during certain times of the day to your clients and automatically install without any administrator intervention whatsoever. Very easy to use, very easy to perform, and mostly it's performed for the client side from group policies. So now here I've got the actual executable that you can download for free from Microsoft. Just go to Microsoft's website and look for Software Update Services, and it'll show you a link for this download. Then you just double-click them, and it starts a handy little wizard for you to do the installation. Now, as we go ahead and click on Next, of course, we'll agree to the license agreement, and then we can specify what kind of installation we want. We can do a typical or a custom installation. Now, what it does is it automatically looks for whichever drive on your system appears to have the most free hard drive space, because this can use hundreds of megabytes worth of downloads, especially if you use a bunch of different languages and you're an international corporation and that kind of thing. Here, I'm just going to use the English language, and I don't really need a whole lot of space for this. But regardless of that, D is a fine drive to use in this case, and this is where it's going to go ahead and install Software Update Service. These will actually be the web files that it's going to install. So if I want those in a different location, I'll have to browse for a different location for the web files. Now then, when it comes to the actual updates themselves, I can store those updates on /sus and then content. That means that instead of using Microsoft's own Windows Update servers to download the content every time, I'll download them one time to this location, and then all of the clients will check with this location through this web page to get their updates. I'll just go ahead and leave it the way it is there, and that looks pretty good. I can also just keep the updates on Microsoft's Windows Update server, and then I'll direct the clients through group policy to Microsoft's own update servers. And then the only advantage for me in that point in using Software Update Services here is I will have kind of a master master list of approved updates, and then the clients can only download updates that I have approved locally here. I'll go ahead and click on next. Here I'm going to do English only. You can do specific languages, and you see a whole bunch of different ones there. For my part, I'm not even too good with the English, so I'll just go ahead and stick with what I've got with English only, and then click on next. And then you can automatically approve new versions of previously approved updates. What that means is, if you've seen an update, you approved it, and then Microsoft came up with a modification. It's basically the same update with just some modifications on it. You can automatically approve of the new versions, or you can manually approve of them if you want instead. I'll just go ahead and click on Next, and then we specify a download URL. This means that in the group policy later on, when I configure where I'm going to point my clients to download their updates, I'm going to point them to this specific location. And at that point, I simply click on Install and let it do its thing, and I'll see you on the other side when this is finished. Well, here it's gone ahead and finished, so I'll go ahead and click on Finish, at which point it takes me right to the sysadmin web page. Now you can just type it in like you see up here, localhost /sysadmin, or you can do the actual name of the system and then /sysadmin. This is actually just the virtual directory, which points me to the software update services content. Now, the first thing you'll probably do here is you're going to have to go to Synchronize Server. You see, right now, this software update server does not have anything that's of any use to anybody, because I haven't downloaded any updates yet. So in order to make that work, I'd click on Synchronize Server, and then I'd synchronize now. You can also do a Synchronize Schedule, and you can see how you can schedule it to certain times of the day and so forth. I'll just go ahead and synchronize now, and then when the downloads are finished, we'll come back and look at what we can do with them. Now, those updates do take quite a while, so I just connected to a different SUS server so I can show you the administration of this. Basically, that's all you've done. Once you've synchronized the server, all you do then is to approve the updates. And there are hundreds of updates to approve, so I'll have to check each one of these items. And I found that if you just use the keyboard instead, and that's deselected, so I select it, and then press Tab twice, and then press the space bar, then that will select the next item. And I just get kind of a rhythm going there so that I can select all these, because there's a couple hundred, there's, quite a few of these different updates that you have to approve of. I wish there was a check all button up there, but there really isn't. So anyway, once we've got all that configured, the only thing that we need to do next after we've approved of the appropriate updates, and you of course will have tested them and so forth, I'm just closing that page, tested them and everything and made sure that you want them to be deployed, then you can go to group policy. And here I've just gone to the default domain policy because I want the entire domain to get its updates from the SUS server that I specified. So for that, you'll go into Computer Configuration, Administrative Templates, Windows Components, and then Windows Update, where we have 4 policies to configure. Now, of these settings, let's go ahead and go to Configure Automatic Updates first, which we will enable, and then specify how we want to configure automatic updating. We can either notify for download and notify for install. This means that the user sitting at the workstation will receive a notification that there is a download available. They'll have to approve the ability for the download to take place, so they'll have to be an administrator. That's no good. And it would also require a lot of user intervention in that case. And then they'd have to be notified for install as well. Again, they'd have to be an administrator to actually install the updates manually using this method. And of course, it requires that someone's actually seated there, so that's not probably the best option. You can also auto-download and then notify for install. This might be a little bit better situation. The automatic downloading of the updates would then be cached and stored locally on the local workstations. And if the user is already using the network bandwidth, then it'll just use spare bandwidth using bits or background intelligent transfer service so that only spare bandwidth will be used to download these updates. And then someone has to be notified of the install, and you've probably seen this on your own XP computers in the past. A little word balloon that appears down here, a little globe that appears down in the feature tray area, says that updates are available. You have to click on it, and then you have to install them. Again, you have to be an administrator to do that. So probably not going to be work best for at least my workstations. Then I'll go to auto download and schedule the install, and for this, nobody has to be seated there, nobody has to even be logged on, and I don't have to have any administrator intervention whatsoever, so for most purposes, for my workstations at least, that's what I'll choose. Then I can schedule the install on whatever basis I want. You see the various options that are available here. Every day is usually a pretty good option for my purposes. And then you schedule the install time, and you schedule it for whatever time of day works for you, 4 o'clock a.m. or whatever. And then we'll go ahead and click on Next to get to the next policy, where we will enable the ability to download the updates from an intranet web server, and that'll be HTTP. And then again, we'll have DC Nugget 1. And then all of the clients will then look for this server to download their updates from. There's also an intranet statistics server, and you can use IIS to log the statistics. Those will typically be stored on the same server, but you can split that up and put it on a different server if you want. Then as we go on to the next setting here, we'll have to specify whether or not we want to reschedule automatically scheduled updates. So if we click on Enabled here, and if the system have to be turned off at the time that an automatic update was supposed to take place, and if we enable this setting, then it'll just wait for 5 minutes after the system starts up, and then it'll automatically update that system. And of course, you can make it as many minutes as is practical for your purposes. And then we'll click on Next to get to the last policy, and we can say no auto restart for scheduled automatic updates. You see, a lot of these updates, especially more of the critical ones or the bigger ones, require a full reboot in order for the update to fully apply. And if we choose not configured or disabled in this case, then what would happen is it would reboot the system and the user might be caught by surprise and have documents that were left open and all kinds of other unexpected results. So we would enable this, and that way the restart would not take place automatically, and we would just have to wait for users to restart as usual. Maybe if they go home during the day and they shut off their computers or something, then that would be the opportunity for the restart to take place when they come in the next day. You'll also be aware of certain software update services files that are critical to this. Here's the actual installation file that's used to install SUS on a server. In order to install it on a server, you have to be running Windows 2000 with Service Pack 3 or greater. You have to be running Windows 2000 as another option that you can use. The version of IIS that's in use has to be at least version 5 or greater. You have to be using Internet Explorer version 5.5 or greater. And you have to install the updates on an NTFS partition only. Now, in addition to that, there's an update client that you can download as well, and that would be the Windows Update Automatic Update client, and that's the version that's available as of this recording. And the purpose of this file is to allow those automatic updates to take place, because you see, Windows 2000 with Service Pack 2 or older machines will not have the capability for understanding the automatic updates. So, you either have to have this file installed, and I would do that through a group policy object, because it's an MSI file, so you can automatically deploy the software using the MSI. I would automatically deploy that to my Windows 2000 clients that were up to Service Pack 2 or older. And then for anything that has Service Pack 3 or greater, you don't need to install this file for Windows 2000, because Service Pack 3 already includes all of these updates. Then as far as Windows XP Professional is concerned, you don't need to use this file for Windows XP Professional as long as it's Service Pack 1. If it does not have a Service Pack applied to it, then you can, again, install this file, and at that point, it will then, by the way, actually install Service Pack 1 automatically, because Software Update Services now supports Service Pack installations. When it first came out, it did not support Service Packs. And then included in this MSI file is also another file, and that's the ADM file, Windows Update Automatic Update ADM file. Remember the policy settings that we just looked at? Well, those are native to Windows Server 2003, but if you're running software update services on an older Windows 2000 machine, it won't have those updates. Well, you can import those particular policies using this ADM file in Group Policy. Well, something like Software Update Services does a great job of protecting us from the latest worms and viruses and stuff like that if Microsoft has a patch for it. But there's also our internal traffic. I mean, for the most part, we're just trying to protect ourselves from internet mischievous users or internet attackers and stuff like that. So that within our own networks, we generally consider the packets that fly back and forth on the wire to be, secure enough anyway. However, there are times when there is secure information that can be picked out of the air, so you might need to make sure that it's either encrypted or that it's authenticated so that you can be guaranteed that the people that are sending and receiving the traffic are indeed who they say they are. So, for example, over here, I'm going to go ahead and start a packet trace on another machine that's outside of your view right now, and I'm logged on here as Bucky Spangler. And by the way, it's kind of an inside joke. If you ever go to Microsoft news groups or anything and you read that some of the admins there are talking about another admin that doesn't look too smart, they call them Bucky. So this is our not too smart user, Bucky Spangler. And he's got Outlook Express going right here, and I'm offline right now, but he's going to start working online, and he's going to send and receive some email. So he receives an email here from his boss, apparently, and there's just a little bit of an inside joke there if you want to take time to read that. It means more if you've ever seen a movie called Office Space. Rent it. It's pretty good. Okay, anyway, so we got a little message here that he got a little bit of trouble for some stuff that he hasn't been doing. What else has he got? Well, he's going to go to the internet and he says, you know what, I got my employee review. They told me my employee review is up on the FTP site. So he's going to go up here to ftp.nuggetlab.com and he's going to enter in his credentials. And of course, it looks pretty secure because, after all, it's a masked password and nobody that's looking over my shoulder or anything can really see what I'm typing. So it must be pretty secure. So he logs in and he sees, oh, here's Bucky Spangler's employee review, and he just decides to open that up and everything. So he reads this and he says, it's a little embarrassing what he's seeing here, but that's all right. At least it's private and nobody else can get to it, right? Well, maybe not, because we're going to take a look at the packet capture that we just made, and we're going to see how that a mischievous user or a malicious user could also use the same information that Bucky has used to be able to find out this same information about Bucky. You see, anybody that's adept at using a packet capture utility, such as Ethereal, which is what I used to capture the trace that was going on while Bucky was checking his email and going to that FTP site, and here's a bitmap image of that utility where I did a packet capture, and you see here that we were able to capture not only his username but also his password, and here it is. It appears in plain text right there. Intelligence. Oh, that's Bucky's password. See, now we see what we call him Bucky, don't we? Intelligence. Oh, that's great. Then we also see here, I use Microsoft Network Monitor to also capture his FTP traffic. Now let's just review quickly how we can filter this out, because since I was doing this over port 3389 for remote desktop, I've got how many packets here? 1,214 packets. Well, I want to see all of those, so I'm going to filter out by clicking the little filter item there. And choosing to edit the expression for protocol equals any, I'm going to click edit expression so I can disable everything, and then I'm going to select only FTP traffic. It'll be a little easier to read that way. And then I'll enable only FTP and OK everything. Now we're only looking at FTP traffic instead. Now if I double click on one of these, then I can see that initially it logged on anonymously. But if I scroll further on down, then we'll see that we have, again, our user account. Here's Bucky. And then we're going to see what Bucky needed to do in order to get into the account. He had to enter in his masked password, remember, which looked so secure. Well, there it is in plain English, plain text again. His password is intelligence. All right. So we see how easy it is to pick out those passwords right out of the air. All right, well, great. Now we know how to hack those passwords, but how we protect ourselves against it for people that have less pure motives than you and I, where we're just trying to see where the holes are instead of trying to exploit them. Well, if it comes to things like the POP password, where you're checking email, that may continue to be an issue. I mean, if you have internal POP servers, like your own Exchange servers or something, and you configure it, you can use secure password authentication, which uses NTLAN Manager to encrypt the passwords. It's not unbreakable, but it's pretty tough, so it's still pretty good. On the other hand, you could also be using external ISPs. Maybe you're a small branch office and you're using an ISP out on the internet. Well, if that's the case, then unless your ISP supports the capability for secure password authentication, and many don't, then you probably will still just continue to have passwords passed in the clear. May not be something you can fix immediately. On the other hand, for things like traffic that goes on inside of our network, for that FTP traffic, for example, or any traffic if you want, you can encrypt all of it. But you use IPsec to do that. Now, keep in mind that IPsec, although it's excellent security, is extremely intensive in terms of processor utilization on both the client and the server, and on network load. Especially on the server, it's going to be intensive for the processor utilization, because it's handling requests from dozens, hundreds, or even more clients at once, and it's going to have to do complex mathematical algorithms to both do the authentication checking for those users, for those packets, as well as for the encryption of the packet contents if you want to use those as well. So it's pretty heavy processor burden. And then as far as your network traffic, there are several additional packets that will be exchanged back and forth across the network, while security associations are being created between the server and the client. And before we get too far with IPsec, we ought to take a look at its functionality. And it can do, first of all, one of these first two options, or both of these first two options. It can encrypt all traffic, and if you use the highest level of encryption, which is triple DES, or 3 DES, Digital Encryption Standard, then computationally it's impossible to reverse engineer that mathematically. It's extremely complex, and nobody's ever directly broken triple DES encryption yet. So that would be extremely secure, but also have a high burden on processor utilization. If you want to reduce your processor utilization, you could go back down to just mutual authentication, and that would just make sure that both parties in a transaction are who they say they are. And if someone else tries to pretend to be me and send you some traffic, well then IPsec will be able to identify that and reject their packets. And there's also dynamic key generation, so that even if someone is able to break a key and figure out a key, well, by the time they get it figured out, there's a pretty good chance that key's already been regenerated, so that old key that they've decrypted or figured out is no good for anything anymore anyway. And it kind of made it just a waste of time for that hacker, poor little hacker. Anyway, there's also the anti-replay capabilities. There's sequence numbers involved in the packet, so that if I send you packet number 10, then the next packet you should see from me is packet number 11. But if instead you get another packet number 10, well, then you're going to reject that. IPsec is going to reject that, saying, hey, that's a replay attack, and someone's trying to modify packets or something and send them back to me. Well, we're not going to do that. There's also packet filtering. You can just be more specific with this, so you can say, I want to allow all packets except for Telnet packets, or FTP packets, or something like that. And those Telnet or FTP packets will be encrypted, or will use mutual authentication, but all the other packets can just pass through in the clear. So you have a lot of flexibility with the packet filtering capabilities there. Now what I want to do is to secure the traffic back and forth between client 01 and my FTP server, ftp.nuggetlab.com, which is DC Nugget 1, which we're looking at right now. Now, in order to do that, there's a couple of different ways. Number one, I could use group policy, and then for whichever container each computer was in, I could right-click on that organizational unit or the domain controller's organizational unit or whatever it was that happens to be where those computer accounts are. In this case, I've got client 01 and desktops, for example. Then I could go to this IP security policies under computer configuration, Windows settings, security settings, and then down here at IP security policies, and if I expand this out, you see that we have 3 settings here that are available by default. Now, let me point out that Microsoft designed these for us pre-built, and you can look at them and explore them and experiment with them if you want to, but Microsoft doesn't really intend for us to use those in actual production. They're more or less templates or guidelines for us to get an understanding of what IPsec is all about. And they will work if you want to use them, if you want to take advantage and implement them, but that's not what they're designed for. They're designed for you to come up with ideas. Nevertheless, we should be aware of what each one of these things do, and also aware of how to actually assign them. If I did want to actually use this one, for example, client respond only, and I wanted to apply that to my desktops in this desktops OU, I would right-click here and then choose Assign, and then you'll see a green little dot appear on the item, and it'll say Policy is assigned over here. Well, I'm going to unassign it right now because I don't really want to do that quite yet. Now, what does that really mean when I select that item and I assign it? Well, for this reaction, for the client respond only, that means that it will send all traffic to all other hosts unsecured, and it will not attempt to authenticate or to encrypt or to do any kind of security with those other hosts. However, when this client attempts to send to a server that has either request security or require security set on it, then this client will receive back from the server a request to establish security, to negotiate security. At that point, the client will say, well, I'm kind of lazy. I don't really like to do security, but if you're asking for it, I'll go ahead and negotiate it with you. And then it'll send back what it needs to complete the negotiation process. Now, if I double-click on it, on most of these policies, we would see something here that would be a filter list and a filter action. We just see here dynamic. That's the only one that's assigned. That's the only security rule that is assigned to the client respond only policies. And if we double-click on that, we see what it can work with. It can encrypt using triple DES or digital encryption standard. It can do authentication header integrity as well. But by default, it won't actually use any of those unless requested by the other party. Now let's go ahead and take a look at this one as well. And by the way, let me also point out that this says client, which gives us the impression of desktops. This says server, which gives us the impression of Windows Server 2003 and so forth. You can put this on a client. You can put this on a server. You can put that on a client. That's just kind of worded that way because that's generally speaking probably how they will be applied, but that's not what you're locked into by any means. Also, you can only apply one of these at a time. I can't assign the client and then also assign the security, because once I do that, it automatically deselects the client, as you can see with the vanishing little green dot there. Now, with this server request security, what's going to happen is any traffic that comes to this server, it's going to allow it to go ahead and come through unsecured, and this is known as inbound pass-through. Then what happens then is it sends back a message to whoever is initiating the traffic, sends a message back to the client, and says, you know what, that was an unsecured packet. I'm a little offended by that. Would you please try to secure anything else you send to me? And if the client can secure the packets coming back, then it will, and that would be, for example, if the client was set to respond only. If this was the server setting, and on my client, if it did have respond only, then it would say, oh, I see you're requesting encryption or requesting some kind of authentication, so I'll go ahead and send it back, and they'll negotiate a session. On the other hand, if that client has no capability for encryption, then the server will just allow it to communicate unsecured entirely, and that's called fallback to clear. And let's also take a look at exactly how it does that. We'll be looking at these things in more detail in the future here. But for right now, I just want to show you how it is that it sets up that request security, but allow traffic to be unsecured if it has to. What we'll do is go to double click on that server request security item, and then it shows me the properties. And then we have certain rules in effect for IP security. In the IP filter rules, we have an IP filter list. In other words, for the first session here, first item, all IP traffic, the action is to request security. Well, how does it do that? If I double click that, I see here that it says all IP traffic. When all IP traffic comes in and it matches this filter list, in other words, any IP traffic, it takes a filter action. And we see that that is also radio button selected here. And if we double click on this now, and I know there's a lot of double clicks here, but we'll review all this again later when we build our own policy. Now we see why it is that it just requests security but allows traffic to pass through unsecured if it has to. It says negotiate security here instead of permit, which would be like the client respond only setting, and then it negotiates the security, and then when it does so, it will accept unsecured communication but always respond using IPsec. And then if that client cannot communicate using IPsec, then this is where the request security would come into effect. It will allow unsecured communication if that computer is not able to use IPsec to encrypt its data. And so that's where that setting comes from. Now, one thing you want to be careful of here is that you do not use IPsec policies on any servers that have direct connections to the internet, because it makes it very susceptible to denial of service attacks. Because you see, if it's trying to communicate with the server, with another host that doesn't support IPsec, there is timeouts that take place there. Actually, there's about 3 seconds before this server even realizes that it's not going to get a good answer back from that destination, and that can happen for each packet. So if you had a distributed denial of service or some other kind of denial of service attack going on with this server, then you're going to have quite a delay with each of those packets coming in while it decides that the other host will not support security. Then the other item you should not use on a public internet is also a secure server, because that will have the same issue. And in this case, it wouldn't be able to communicate at all if the destination host did not support IPsec. Now, what happens with this is it will allow traffic to come inbound. So, in other words, it does allow inbound pass-through. And that can be insecure traffic. However, when it responds, it always sends back a negotiation to start security. And if the host that's sending the traffic back to negotiate security does not support security, then it will no longer allow outbound packets to that host, and the communication pretty much just stops right there. However, if the original host that sent this unsecured packet in the first place continues to send additional unsecured packets, then the server will continue to try to negotiate security, which you can also see makes this extremely susceptible to denial of service attacks, because someone could send out hundreds or thousands of connection attempts to this server at a time, and since it's so processor intensive, all of the kind of authentication procedures we use here, it can really lock that server up with a bunch of bogus attempts to negotiate security. And so again, you don't want to use that on the internet. Now let's go ahead and take a look at how it does its job. Here again we have with all IP traffic. What does it do? Well, if I double click on it or click on edit down there at the bottom, it shows me that for all IP traffic, which is selected here, it's going to take this filter action, which is to require security. If I double click on that, it looks very similar to what we saw before. With the require security option that we looked, or rather with the request security option that we looked at before. However, it is missing this checkbox that we had before. So in other words, fallback to clear is disabled, and that's why it will not allow communication with unsecured computers or non-IPsec aware computers. Let me also point out that if we had gone ahead and applied one of these security settings and it didn't work, and we had serious problems communicating with the servers or clients we want to communicate with now, do not ever just delete a policy. This could be one of these pre-configured ones here or a new one that you create yourself. Don't just right-click here and choose delete. The reason why is if it's in a policy like we've got here, notice this is in a group policy, then any clients that have read this have already downloaded the policy to their local systems and they've cached it locally. So if I delete this, they will continue to attempt security using IPsec, and there's no instruction not to use it. So what I would have to do first, if this policy here was really bad and it blew something up or something, I'd right-click here and then just choose unassign like I did a moment ago. Once then, I'm sure that all my clients have read this new policy. Maybe they've shut down and restarted or something like that. Then at that point, I would then be able to delete it if it was really causing a problem. Now in this series, as well as many other series that I've taught, you might have heard me say that if possible, do everything by group policy objects instead of going to individual systems and manually configuring everything there, because that's extremely time intensive and it's less practical. Because a group policy item will apply to dozens, hundreds, maybe even thousands of objects at a time, whether they're computers or users and so forth. Well, with IPsec, it's less likely that you'll use group policy objects for that, because, for example, I might have an organizational unit full of servers. It's got 100 servers in it. But there's only one server in there that has extremely high security requirements that I would want to apply IPsec to. Well, I'm not going to use a group policy object then with my security settings here for IPsec on that entire OU. Instead, what I'll do is I'll open up a different console, an MMC console, or I've added in the snap-ins myself for the local system only. In order to do that, I'm going to go ahead and go to an MMC console, so I'll just go to Start Run, type MMC, click OK, and you've seen me do similar things to this before, I think. And then you just go to File, Add Remove Snap-in, and what I'm interested in adding here is IPsec stuff, so we'll go down here to IP Security Policy Management and IP Security Monitor. I'm going to double-click on IP Security Monitor because we'll be using that later anyway. And then I'll also go to IP Security Policy Management. Then it asks me where I want the focus to be when I double-click on this, be the local computer, the Active Directory domain of which this computer is a member, or another Active Directory domain, or a remote computer. I'll just do the local computer in the case that this might be the single system that I want to isolate in terms of IPsec and want to protect in terms of IPsec. So then I'll click OK through all the rest of it, and we'll see that we really start off with the same exact policies that we had in the group policy object, and here they are. And then in our next nugget, we're going to see how we can actually create our own policy from scratch and apply it to the system. In this nugget, we continued our discussion of security, and this was part 2, where we started off with a discussion of SUS, or Software Update Services, which you can install on an Internet Information Server, and it allows you to automatically deploy updates to all of your clients, provided you have the appropriate group policies also configured. We also took a look at how to inspect packets that might be insecure. Use Network Monitor to do that, or third-party tools if you like as well. But regardless of what you use, there are passwords that can be passed around on the network that you might not even realize are being insecure. Well, if you need to secure some of those packets, you can use IPsec, and we saw that you have several different functionalities within IPsec. For example, we saw that you can authenticate the header so that you can verify that both the sender and the receiver are who they say they are. And you can also encrypt the payload as well. Then we also took a look at the default security policies there for IPsec, and you can use those if you like, but mostly they're there for our learning. And then we also saw how to deploy the policies using a group policy object, or to create a local policy instead and deploy it that way. I hope this has been informative for you, and I'd like to thank you for viewing.